Second goal on 5.8 is called finding rational zeros. So basically we've been doing this on 5.5, 5.6, 5.7, and now we're doing it again on 5.8. Okay, so the first or second example here in this section is volume of a rectangular prism is 1,056 cubic centimeters. Okay, so here's a rectangular prism. The length of the rectangular prism is one more than the width. So if the width is W, the length is W plus 1. And the height is 3 less, so W minus 3. So we know that the volume of a rectangular prism is length times width times height. So 1,056 is equal to W plus 1 times W minus 3. Now, to solve this, we need to multiply these together and then subtract 1,056 over. So if I multiply these together, I get W times, I'm going to multiply these first, I get W squared minus 2W minus 3, so that's W cubed minus 2W squared minus 3W, and then I'm going to subtract 1,056 over, so we're looking at this equation right there. Now, if we can factor this, we should. If we can't factor this, then we might want to use the calculator to help us find a zero on the table or on the graph or something like that. And I believe that W is equal to 11. When I look on the calculator, I plug this into Y equals, and I look at the table, W is 11 is a 0. And I want to make sure, yeah. So 11 is a 0 for this polynomial function. So it asks us for the dimensions of our rectangular prism. So obviously our dimensions are 8 by 11 by 12. So there is the answer to example 2. Okay, so now I'm looking at 3A. 3A says all it says is find all the zeros. So we've talked about many techniques to doing this, namely factoring. Secondly, using a calculator to find a zero and then factor if we can. In this case, we have a unique situation where it's factoring using quadratic form. So let's go ahead and try and factor this and see what happens. Okay, so using quadratic form, I know this is x squared and x squared. 2 factors of 9. 3 and 3 would be a good thing to try, but in this case, I believe 9 and 1 is a better way. If I put a minus 4 and a plus 1 here, I know that negative 4x squared plus 9x squared is 5x squared, and negative 4 times 1 is negative 4. So that's the factored form. Now, I'm looking for 4 zeros because it's a 4th degree polynomial. 2 of the zeros are in this quadratic, and 2 of the zeros are in this quadratic. So let's say these 2 zeros are x squared plus 1 equals 0. So x squared is equal to negative 1. So x is equal to plus or minus I. So positive I and negative I would be 2 of my zeros. The other 2 zeros here are in this one, so I set that equal to 0. Add 4, divide by 9. So x squared is equal to 4/9. Take the square root. X is equal to plus or minus 2/3. So 2/3 and minus 2/3. So there are our 4 zeros. Now I could have factored this instead, factored by difference of 2 squares. If I factored this instead, I get 3x minus 2 and 3x plus 2. And of course, those are both answers, plus or minus 2/3. Okay, So that's an example where I didn't even need my calculator. I just used my factoring techniques to do that. Okay, so now this one is, doesn't look like it factors. It's quartic. There's no factoring by grouping that we could do there. So we're going to go ahead and try to find a factor on the calculator. Okay, so if I go ahead and punch this into the calculator, all right, so I've actually got it entered into my calculator already. So I entered it in here. Okay, so I'll see if you can see that. And then I'm going to go to the table. And if I go to the table, I can see that 2 is a 0. So I'm going to go ahead and factor out a 2. I should say take out a 2 or factor an x minus 2 out. So I know I'm looking for 4 zeros, one of them being 2. And then I want to find out what's left here. Okay, so I do that using synthetic division. I've got 2, negative 5, 20, negative 45, and 18. Drop 2, multiply, negative 1, negative 2, 18, 36, negative 9, negative 18, and sure enough it is a 0. Now, if I scroll up and down on my table, I do not see any other zeros. So then I go to my graph. And my graph, if you can identify your graph, it looks like between 0 and 1 is a 0. So if I use the calculate 0 key, above and below, or left and right of it, it says 0.5 is a 0. Well, that's nice, because if 0.5 is a 0, or 1/2, I can go ahead and right here. So basically I'm taking an x minus 1/2 out. So I drop the 2, multiply 1, 0, 0, 18, half of 18 is 9. Sure enough, that's a 0. So that leaves me with 2x squared plus 18 as my other factor. Now don't forget the x minus 2 is still out here. So I have a linear factor with a 2 being a 0. I have another linear factor with 1/2 being a 0. And I have a quadratic factor that has the other 2 zeros in it. Since it's quadratic without an x term, I can go ahead and set this equal to 0 and solve. So 2x squared equals negative 18, x squared equals negative 9, take the square root, x is equal to plus or minus 3i. So my 2 other zeros are 3i and negative 3i. All right, so that should get us all 4 zeros. I'm just making sure that you can see everything that I was doing. This is exactly what we've been leading up to. It's been what we've been doing for the most part this second half of chapter 5. Using factoring techniques, using finding zeros techniques, being able to factor things out, and then being able to identify all the zeros, whether they are real or imaginary. That is the key. Okay? So hopefully you've been able to keep going with all of this material. You're able to understand what we're trying to get across. You need to let me know if you need help with any of it so you can make sure you understand how to do it. We're going to be using these techniques later too, so it's very important.